x right now, it can be either like, it can be here or it can be here, but here is inside the rectangle, and we said it can't be inside the rectangle. So it has to be outside. And it's the same thing with y. Y is essentially a symmetric version of it. It would just be down here. Like again, using the lengths, it could have also been in here, but we said it's not in the rectangle, so it's outside. This is 6, this is 10, this is 8. Now, so there's one thing that we have to notice here. This is part of how we're going to solve this question is 6, 8, 10 has a very nice relationship that you might be familiar with. It satisfies the Pythagorean theorem. So that means that these lengths, they're right triangles. So what you do is, so I'll just draw it a bit nicer. So that looks nice.
Y is 8. Okay.
So now that we know they're right triangles, what we want to find is we want to find x, y, right?
It's a right triangle.
So this is actually pretty complicated. It's not immediately evident how you would solve this question. But like one thing that we can try to do is we can try to decompose it into like its parts. Because right now it's not a straight line, so how would we figure out? Well, let's consider what the height would be, right? And what this base would be. So we find out this length, which I'll call it y, and then the base, which is x. Okay. So, I mean, what immediately pops out is that that y is equal to this height. I'll call it h. H times 2h plus 5 will be equal to y. And then x, well, we're not really sure what x is right now. But let's start with y, because we can figure out x later. So if we want to, well, we already have our formula, so all we need to do is figure out h. So how do we figure out h? One thing that's nice about h is that it's an altitude. So we can figure out the area of the triangle. We can relate the area of the triangle to the lengths. And we have two right triangles here, right? We have this base and this height, right? So like, here, let me just redraw this. Let me draw D, Y, C. You can write the area of the triangle in two ways. So this is 8, this is 6, this is 10. So the area of the triangle is 8 times 6 over 2, right? This is just base times height over 2. But then we also have another way. And obviously the area of the triangle is always going to be the same. This base is DC, which is 10 times h over 2. And now we just solve for h. So multiply both sides by 2, divide both sides by 10, and you get h is equal to whatever this is. What's 8 times 6? So we know h is 24 over 5. Okay. So that immediately gives us what that y part is, right? But we need more than the y part. We also want to know what this x component is. So what we might do is we might think that it looks kind of symmetric here, right? If we drop the altitude from here, you will notice that if you just drew this kind of square-looking shape. Oh yeah, it's 4 o'clock now, so if you guys have to leave, that's fine. I'll just finish this problem and then maybe go over problem 15. When you're at home, I would really recommend trying problem 15. That's actually a fun problem that anyone can do. So yeah, so now all that remains is that, well, what we want to do is we want to find this length, because we might see that x is equal to this entire length DC, which is 10, minus 2 times this base here, because these bases are the same. So minus 2 times, I'll call it. Okay, so how do we figure out B? We use similar triangles. So I'll call this, hopefully, maybe you're not familiar with similar triangles. This is, I think you learned in grade 9 or grade 8, I'm not sure actually. So she'll find that DCY is going to be similar to YDC. So you have a ratio, you have H over EC is equal to 6. So this is how you relate similar triangles. You know that similar triangles, the way that similar triangles work is essentially one is a scaled up version of the other. So the ratio of the side lengths of two similar triangles are always going to be the same. So the idea is like the ratio of these two and these two are going to be the same because they're similar triangles. So if I were to solve for EC in this case, because we know H is 24 over 5, you so we have EC. So now if we just plug in our two formulas, this will be so using our two formulas, which are kind of ugly, we get y is 72 over 5, and then x is 14 over 5. We know it's a right triangle, so then we just use Pythagoras. And I'm not going to bash it up. Honestly, this problem is a bit annoying because the numbers are pretty big, but I'm pretty sure what you get is, we get something that looks like this. And this gives you square root 221. Anyone have any questions? Yeah, you can try them at home. Oh. Is there a single part you got?
It's 73 over 5, right?
Is it 70? Let me see.
So 25 plus 48.
No, it's 73.
Yeah, that's it.
Thank you.
Thanks. Arithmetic is hard.
Oh, the 4.
So yeah, this is like this would be like maybe on the level of the hardest problem on the exam. Except there is problem 15. I think problem 15 is actually easier. So, but like, give it a try.